Guillaume de l'Hôpital was born in Paris, France in 1661.
It's a boy.
Okay. Outside his window. Guillaume de l'Hôpital.
At school, l'Hôpital disliked many subjects. However, math was different.
Guillaume, please, pay attention.
His math skills were evident when he was able to solve a problem that stumped most mathematicians at the age of 15.
Bruh, look at this dude. Wait till you see the. No. Look at the top of his head.
Hey l'Hôpital, there's this problem that has stumped many mathematicians. It's this cycloids problem by Blaise Pascal. Would you like to try it?
Sure, I'll give it a go. Ooh, I solved it.
Wow, l'Hôpital, you're only 15. Good job. L'Hôpital came from a military family, as his dad was a lieutenant general and his mother an intendant of the king's army. However, due to poor eyesight, he abandoned a military career to pursue his interest in mathematics.
School's over. Guess I'll be joining the cavalry. Oh wait, I can barely see things from far away. I don't think I'm fit for the army. I'll continue doing math instead.
For a while, he was a member of Nicolas Malebranche's circle in Paris. It was there that in 1691 he met young Johann Bernoulli. Bernoulli was a Swiss mathematician who was visiting France and agreed to give lectures on infinitesimal calculus. These lectures caught the eyes of l'Hôpital, who had a desire to learn more from Bernoulli. Hey l'Hôpital, how did you like the lecture I just gave?
It was quite intriguing, but I have a proposition for you.
What is this proposition?
I will pay you £300 on the 1st of January, and it will increase over time. In return, I request that you share with me some of your research and discoveries.
I accept that proposition. Bernoulli taught l'Hôpital what is now known as l'Hôpital's rule. Okay, l'Hôpital, let me teach you something new. What if you wanted to find what f of x over g of x was, but f of x was equal to 0 and g of x was equal to 0? Clearly it's in a determinate form, but what if I told you that this was equal to f prime of x over g prime of x? And let me show you how. Well, like I previously said, let's say we had f of a over g of a. And I told you that it would be equal to f prime of a over g prime of a if f of a and g of a were both equal to 0. And this is why. Let's work backwards. F prime of a, the definition of the derivative would be the change in f over the change in x. And that's the same as saying f of x minus f of a over x minus a. We can do the same thing for g prime of a, as its limit definition would be the change in g over the change in x, which is g of x minus g of a over x minus a. Now, we can rewrite f prime of a over g prime of a as f of x minus f of a over x minus a all over g of x minus g of a over x minus a, just plugging in these two values here. And simplifying it by cancelling x minus a gives us f of x minus f of a over g of x minus g of a. And here we defined how f of a and g of a were both equal to 0, so those two cancel out. And we're left with f prime of a over g prime of a is equal to f of a over g of a, which tells us that when it's indeterminate, f of a over g of a is equal to f prime of a over g prime of a, when f of a and g of a is equal to 0. L'Hôpital also received help from many other famous mathematicians, including Gottfried Wilhelm Leibniz, Jacob Bernoulli, and Johann Bernoulli. With the concepts learned from these mathematicians, L'Hôpital wrote the first ever differential calculus textbook, which has a name that translates roughly to Analysis of the Infinitely Small to Understand Curved Lines.
It was in this book that L'Hopital first published L'Hopital's rule. It is now a commonly used rule to evaluate the limits of indeterminate forms.
Okay, well, now that we're in real time, the previous proof, while it was also simplified, did not account for when we have the indeterminate form of positive or negative infinity over infinity. So I would like to point out that that previous proof was not the actual proof, but a much simplified version. However, the actual definition of L'Hopital's rule was the limit as x approaches a of fx or g of x is equal to the limit as x approaches a of f prime of x over g prime of x, when either the limit as x approaches a of fx or g of x is equal to 0 over 0, or plus or minus infinity over infinity. Now, we'll do a problem to show L'Hopital's rule. Let's say we have the problem limit as x approaches 0 of x over sine of x. Well, we know that as x approaches 0, x becomes 0, and as sine of x approaches, as x approaches 0, sine of x approaches 0 as well. So we can do L'Hopital's rule where we take the derivative of the top and the bottom. The derivative of x is 1, and the derivative of sine of x is cosine of x. So as x approaches 0, 1 becomes 1. As x approaches 0, cosine of x becomes 1. So this evaluates to 1, which means the limit as x approaches 0 of x over sine of x, using L'Hopital's rule, equals 1.
L'Hopital died in Paris on February 2nd, 1704, at the age of 43.
L'Hopital continues to be well known for the work he published in differential calculus, especially L'Hopital's rule.